Hey, good morning everyone. Today we're going to do a little bit of work on fractions. So for some of you, you may have learned about fractions last year. So some of this may be a little review, a little bit of a refresher, and that's okay. And for some of you, you may be wondering, what is a fraction? So a fraction shows equal parts of a whole. Let's take a look at an example here. Let's say we have one whole pizza. That's a lot of pizza for one person, so we're probably going to cut it up. And since that's a lot for one person, let's say I want the pizza to myself, but I'm going to have it on 2 different days. So let's say I cut it in half. Now I have 2 different pieces of the pizza that are both the same size. They're equal. Let's say I eat half of the pizza. I eat one of the pieces of pizza. So the blue part of this pizza is the part I ate. So I've eaten 1 out of 2 pieces. So we can use a fraction to explain what part I've eaten. So I've eaten 1 out of 2 pieces. So we have 2 pieces. So I have a 2 at the bottom and 1 piece I've eaten. So there's 1 out of 2 pieces I've eaten so far. Now, what are these numbers called? Why is this on top? Why is this on bottom? So the top number is always called the numerator, and that's the number of parts counted or separated, our numerator. And the bottom number is our denominator, which is the equal pieces of the whole. So we have 2 equal pieces of pizza. So that's our denominator. And our numerator is the number of parts counted or separated. The part I ate 1 of the 2 parts. So 1 over 2 or half of the pizza I've eaten. Okay, I got a new piece of pizza here. A new pizza. And so how many, if we're going to just make a fraction out of this pizza that we just took out of the oven, we just cut up, let's do this. Denominator, how many equal pieces of the whole are there? Well, there's 1, 2, 3, 4 pieces of pizza. So the 4 would go on the bottom because it's the denominator. It's how many equal pieces of the whole there is. 1, 2, 3, 4. And now, how many numbers, what's the numerator right now if we haven't eaten anything? The number of parts counted or separated. It's still 4. So we have 4 out of 4 pieces of pizza. Now, what would happen if I ate 1 of those pieces of pizza? So what would our fraction be of how many pieces of pizza are left? So our denominator would be still 4, because the equal pieces of the whole, we had 4 equal pieces. 1, 2, 3, 4 equal pieces. And we're counting, so our top will be our numerator. We're counting the parts that have been, the number of parts counted or separated. The number of parts we're counting are the parts that are still left. So we have 1 part left, 2, 3 pieces of pizza still left. So we have 3 over 4, or 3/4 of the pizza left. Now what if we have our 4 pieces of pizza and I eat 2 pieces of pizza? What is the fraction to represent what we have left? So our denominator is still 4 because we had 4 equal pieces to start with. And our numerator, how many pieces of pizza do we have left? 1, 2. So our numerator is 2. We have 2 of the 4 pieces of pizza left. Or you can say half of the pizza is left. So this could be represented as 2 out of 4, or 2/4, or half. So we could also write it this way. But don't worry if you don't get that right away. If I only had 1 out of 4 pieces left, we would write it as 1 over 4, or 1/4. We have 1 piece of pizza left out of 4 pieces. We have 1/4 of the pizza left. Now remember, we talked about a fraction shows equal parts of a whole. So they have to have equal parts to be able to be explained as a fraction. So look at this circle here. It's much like our pizza pie. Let's see if I can get something that you can see a little better. This circle, the pink circle here on the left, it's cut up into how many equal pieces? 1, it has 1, 2, 3, 4, 5, 6, 7, 8 equal pieces. So our denominator would be 8. And how many are pink? 1, 2, 3. 3 out of 8 pieces of this circle are pink. 3 over 8. Now, we could do that because all the pieces that are the exact same size. They're equal. This circle over here is unequal because, look, are all the pieces the same size? Is that the same size as this piece, or is this piece the same size as that piece? No, they're unequal pieces, so we can't make a fraction out of it. It doesn't quite work, unfortunately. So all fractions show equal parts. Let's do a couple fractions together. So here we're going to match these fractions together. At any point you can just pause. You may want to just pause right now and do it by yourself, and then see if we got the right if you had the right idea. So this one right here, let's do this one first. How many pieces are there to this circle, and are they equal? Yeah, they're both the same size, both pieces, so they can be a fraction. How much of it is shaded or colored? We have one piece of it colored and one piece of it not colored. So one piece is shaded, so the numerator, the top number should be 1, and the bottom number, how many equal pieces in total? 2. It's split up into 2 pieces. So let's find, match it to what should be 1 over 2, or half. Half of it is shaded. So there it is. So if you did that, you're correct. Half. Okay, next one. Right here. So how many pieces are there? 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 as our denominator. And our numerator, how many are colored? 1, 2, 3. 3 over 8. So we're going to see, oh, there it is right there. So we're going to match this one right here. How many pieces are there of this whole? 1, 2, 3, 4. They're all the same size. So our denominator should be 4. And our numerator, how many are colored? 1, 2, 3. 3/4 or 3/4. So we're going to match. We've got 1, 2, 3, 4, 5, 6 pieces here. And again, pause if I'm going too fast. And you want to do this. 6. And how many are colored? 1, 2, 3, 4, 5 out of 6. So we're going to find that, and we're going to match. And finally, 1, 2, 3. And we have, so 3 equal pieces, and 2 out of 3 are shaded. And there should be one last one that says 2. Oh, perfect, right there. So 2 over 3. 2/3. Awesome. Now I'm not going to go over these, but take a moment just to pause the video here, and I want you to try matching these to the picture that's shaded. Now sometimes we'll have set fractions, so it's not necessarily one whole, but there's multiple pieces, and we're going to represent it with a fraction. So how many pieces are there? How many circles are there? 1, 2, 3, 4, 5, 6. So in the whole set of this, we have 6. That would be our denominator. And let's say we had 4 red circles, and we were asking how many of our circles are red out of the set. We would say, well, we have 1, 2, 3, 4 out of 6 circles are red. Oh, and even it's red 4. 4 of the 6 in the set, 4/6 of them, are red. Let's say we went to the gym storage room and we were counting the number of balls in a bag. We have 1, 2, 3, 4, 5 balls in total. That's our denominator. We have 5 in total. And let's say we said how many of them are soccer balls. So we have 1, 2, 3, 4 of the 5 are soccer balls. 4/5 are soccer ball. What if we say how many of them were basketballs? Well, how many are basketballs? 1 of them out of 5 are basketballs. 1/5 of them are basketballs. Let's say we are counting how many pets there are in this picture. And then we say, what is the fraction of the number of cats? What is the fraction of the number of cats? So what's the total of the set? We have 1, 2, 3, 4, 5 pets. And they're asking how many of the 5 pets are cats. 1, 2, 3 of the 5, or 3/5 are cats. If they asked us the same question, how many of them are dogs? Well, we have 5 in total, so that's still going to be our denominator. 1, 2, 3, 4, 5. And in total, there's 1, 2 dogs. So 2/5 of the set are dogs. Let's say I have 1 bar. Let's say pretend this is a chocolate bar, even. So I have 1 bar. That we can say is a whole. We have 1 whole bar. Now, let's say I cut it into 2 pieces. We have 2 halves now. 1/2, 2/2, 1/2, or like we call it when we have something and we cut it in half and cut it into 2 pieces, we have halves. So right now I have 1/2 and now I have 2 halves. Or together that makes 1 whole. If we split something up into 3 pieces, those are called thirds. I have 3/3 now. 3/3 now. Now I have 2/3, and I have 1/3 now. If I split it up into 4 pieces, those are called fourths. We call them fourths. So if I have 1 whole chocolate bar, and I split it up into 4 pieces, I have 4/4 right now. Now I have 3/4. This lighting's not very good here. 3/4. 4/4, 2/4, 1/4. If it's in 5 pieces, which isn't on the picture on the left, but it's fifths, I have 5/5, 4/5, 3/5, 2/5, and 1/5 left. If we have, I'll just show you this quick. If we split the bar into 6 pieces, they're called sixths. If you split them up into 8 pieces, they're eighths. If you split them up into 10, they're tenths. Each piece it's a 12. If it's split up into 12 pieces, each piece is a 12th. 1/12, 2/12, 3/12. But don't worry about that too much. Just wanted you to get the terminology if we're making a fraction, that you know what the denominator would be called and why it would be called that. So you may want to pause the video here. This is the end of the video, but this is going to be your homework. So what you can do is get a piece of loose leaf, and you see how it says each picture has a letter beside it. So this is A. So I would do a fraction for each of these letters, each of these pictures. And then these are at the bottom here, V, W, X. Those are set fractions. So you're just going to represent those as fractions. So just on a piece of paper, just start with A. And the fraction is, and you're just going to write it, whether it's 3/4 or maybe it's 5/6, whatever you think it is. Then you'd go to B. I'm going to look at B on here. So I know the denominator. I see there's 2 parts to the circle. And I should mention, you're going to write what is shaded or what is colored. So for B, and of course this is not the right answer for A, but for B, 1 out of 2, or half of it, is shaded or colored green. So then I go to C. It's the orange part. How much of it is orange? Well, there's 3. Denominator is going to be 3. There's 3 equal parts. And how much of it is color. So you're going to fill that in. So you're going to do that for all the letters. And